So I grew up in Nova Scotia, and one of my favorite places to visit along this coast was called the Long Island Sea Arch. And it's this amazing hole that goes right through a cliff in the Bay of Fundy. And in October of last year, some hikers went to visit this arch because it's a bit of a tourist attraction, and they found that the entire structure had collapsed overnight, and the arch was now just rubble. And this was really surprising and actually a little bit upsetting to a lot of maritimers, because this arch had been around for thousands of years, and then overnight, the entire structure changed. And in biological systems, we call this type of change a regime shift. And this happens when an ecosystem is pushed past a critical threshold where all of the feedbacks and the reinforcing processes that keep an ecosystem in that structure are overcome, and the whole system reorganizes into a new regime. And it's important to study this type of change because these regime shifts can often create structures that have entirely new ecosystem services and function in really unexpected ways. They're also, just like this arch, hard to predict and really difficult to recover. And one of the best examples of a regime shift in marine ecosystems actually happens right off the coast of Nova Scotia, in our kelp beds. And kelp beds are, you can think of them as underwater forests that grow along the rocky shores of Nova Scotia. And just like a forest on the land, they provide habitat and food for a lot of organisms, like fish, and lobsters, and crabs. And regime shifts occur in these systems when the main grazer, this tiny sea urchin, which you can think of like a small hedgehog that's covered in spines, increases in densities over a critical threshold where it overgrazes all of the kelp and transitions the whole system to bare rock. And this is a photo of this happening right at the entrance to Halifax Harbor. So the goal of my thesis was to investigate the drivers of this shift to sea urchin barrens, and specifically looking at the role that sea urchins in offshore, deeper areas played in driving shifts in the shallows. So the first thing I had to figure out was where sea urchins were in deep regions. So using scuba diving and underwater cameras, I took videos of the entire Central Atlantic coast, analyzed 44,000 images of the seafloor, and found that sea urchins were actually in these deep, localized pockets along the coast, and that they were right beside areas that shifted to barrens. So this is important because I can identify the parts along the coast that are more vulnerable to regime shifts. And it's also important because we're in a time of unprecedented change, and understanding the dynamics that push systems past this change is a critical challenge that we're facing in ecology.